Good day, wherever you are. I want to take you through Form 4, Chapter 6, Longitudes and Latitudes. So, this topic, we are expecting this topic in Paper 2 this year. Therefore, I want to take you through the things which makes you think that the topic is very difficult. I want to take you through. Be patient. I will take some little time. I'm not going to talk much. I want to give you the knowledge, the specific foundation that you need to tackle longitudes and latitudes. I want to make it simple, easy, and enjoyable. Welcome. Longitudes. Longitudes and latitudes are found where? They are found on the globe, on the Earth's surface. We live in the Earth. Therefore, we have the longitudes and latitudes. So let us look at the globe, the Earth. That is the Earth. The Earth has been divided into two by the equator. This line equator is at the center of the, so this is 0 degrees, and it is called the equator. It is called the equator. So from the equator up, from the equator towards this direction, this is north. From the equator, this down is the southern hemisphere and the northern hemisphere. From 0, so the equator divides the globe into two. Very nice. That is the key word you need to go. So from here 0, the maximum north we reach here is 90 degrees, 90 degrees south. So from 0 degrees equator, this line is called the latitude. A line which goes across the globe is called the latitude. So that's another thing now we want to know. This line, the equator, is the major latitude that we have. We have other latitudes. We can have this latitude here. We can have another latitude here. Actually, it forms a circle. If you do like this, it forms a circle. That latitude, as it goes like that, it forms a circle. This one also, it goes like this and forms a circle. They form circles. So these are the circles. They form these latitudes, they form circles with the diameter. They have a diameter inside here. So this line, whether it is this one or it is this one, they are called latitudes. So those lines that are going across, that go like this in the globe, like this, they are called latitudes. Please note that. Otherwise, when you don't understand that, that is why the topic becomes very difficult. Number 2, I will draw another globe to explain the longitude. The longitude, let me sketch another globe like this, with this and then I will draw the equator. The equator is the reference latitude. Now I will draw another line at the center here and call this one Greenwich meridian. So the Greenwich meridian also divides the globe into two. To the west, this is 0. The Greenwich meridian here at the center is 0. So towards this direction, it is to the west. Towards this direction, it is to the east. So it goes like this until it comes this side here. It covers 180 degrees to the east. When it goes to the west, it goes this way until then it reaches here. It covers 180 degrees to the west. So the Greenwich meridian tells us you are on the western side of the globe, or you are in the eastern side of the globe. Please note that. After saying that, now I want to let you know about the great circle and the small circle on the Earth's surface. Now, this is the most important. Great circle and small circle. If you know that, this topic will go nowhere. So let me take you slowly here. I want to draw a globe again. Let me sketch the globe. Once you sketch the globe, there are two lines that you are going to draw, and we call them the reference point. Number one is the equator. Number two is the Greenwich meridian. Those are the two lines that you draw in any globe, in any Earth surface you draw. You need to get. So the first thing, draw the equator, ambayo inagawa the Earth into two hemispheres, upper hemisphere, lower hemisphere. Next, draw the Greenwich meridian, which divides the globe into the west and the east, and here is a 0. So you draw the equator and the Greenwich meridian. So you see the equator divides the Earth into the upper hemisphere, and so this is the 0, and this is our equator, and this is the Greenwich meridian, which is 0 here. Now we want to talk about small circles on the Earth surface and great circles. A small circles are found in all the latitudes above the equator and below the equator. So if I draw this equator, it is the only latitude that forms a great circle. So the equator, it is the only latitude that forms a great circle. The other latitudes, like if I draw this latitude here, which is, for example, 2 degrees south. If I draw another one here, this one could be 40 degrees south. If I draw this one to make a circle, this circle cannot be a great circle. Why? It does not divide the globe into two. A great circle ni ile circle ambayo inagawa the globe into two. And the only latitude that do that is the equator. So anything else that is above the equator, 50 degrees north, anything that is above 0, that is 1 degrees north, 2 degrees north to 90 degrees north, all of them are small circles. Did you hear that? All of them are small circles. Very nice. Now let me go to great circle. So great circle, the only latitude that is a great circle is the equator. Equator, it is the only one that forms the great circle. And the equator is 0 degrees. All latitudes. So these lines, I have talked about this, that was they are called latitudes. The lines which are drawn alongside like this. Let me sketch another globe. This is the equator, and this is the. So these lines that are drawn like this, all of them, they are called longitudes. That the lines that run from the north to the south. These lines to the south, they are called longitudes. They are called longitudes. All of them, all longitudes are great circles. Kwa sababu any of them, ikienda hivi, ikikuja hivi, inagawa the globe into two. So all latitudes, longitudes, all longitudes are great circles. They form great circles. That is the information that we need to understand this topic. All longitudes are great circles, all of them. The only latitude that is a great circle is the equator. All other latitudes are small circles. We are going to see how we are going to apply that knowledge. The next thing we need to know is how to place a position on the Earth's surface. The position on a place on the Earth's surface. the position of a place. The position of a place on the group, on the Earth's surface. How do you put a position on the Earth's surface? For example, I will tell you A is 50 degrees north, 70 degrees west. So I want you to note that this is the coordinate of a point on the Earth's surface. Now I've talked about the latitude and the longitude. The position of the Earth is given by starting with the latitude, longitude. Umesikia hiyo kweli? If you confuse it, then you are not going to score anything in this maths. The first coordinate is the latitude. The second is the longitude. The second is the longitude. So, if I have A, this place, and then B is 50 degrees north, 40 degrees west, east. We want to sketch and place this coordinate on the graph tuweke hizo position kwa earth surface. So rule number 1, you sketch the earth surface. Once you do that, you draw the reference point, the equator 0, and another reference point, the Greenwich meridian. Here you are 0 to kwenda huku ni west, kwenda huku ni east. Here we are 0, kwenda juu ni north, kwenda chini ni south. So the first coordinate we have A, we have 50 degrees north. So north hiyo ni latitude. Kwa hivyo tunaenda hapa 50, inaweza kuwa kitu hapa. Unachora hiyo line. Kisha chora unaandika 50 degrees north. And then hiyo the same one equals 70 degrees west. So from this 0, from the Greenwich meridian, west ni kwenda hapa. So we know 70 degrees north can be somewhere here. So this is the line, the longitude 70 degrees west. Yes. So where the two lines meet, that is where we have the point A. So here is where we have point A. So this is point A. Let's put point B. Point B is 50 degrees north. So they are on the same latitude. So it is somewhere here. And then 40 degrees east. So from here 0, the latitude, the Greenwich meridian to this side is east. So 40 east inaweza kuwa kitu hapa. So here it is where we have our B. That's our B. So that is, so A iko hapa, B iko hapa. Na tumeiweka on the graph. I want to do another one. P, which is 50 degrees north, 70 degrees east. Q is 30 degrees south, 70 degrees east. So when you look at this one, they are on the same longitude, but different latitudes, right? So what we do, let us start. Rule number 1, draw the group. I have drawn the group. The reference point, the equator 0. The reference point, the Greenwich meridian. From there now, 50 degrees north. This is 0, 1, 2, 3 mpaka 50. 50 inaweza kuwa hapa. So this is 50 degrees north. Nimeshaweka P, and then 70 degrees east. So 70 degrees east Kama hii ni 0, then hapa ni 10, 20, 30, 70 inaweza kuwa kitu hapa. So 70 degrees inaweza teremkia hapa ikuje hapa. So hapa ndio tuko na point P. Tuende point Q. Point Q iko 30 degrees south. Kwa hivyo the equator ni 0. So 30 degrees south inaweza kuwa hapa. Unaandika 30 degrees south. Ukishaandika 30 degrees south and then they are on the same this line. Remember this is 70 degrees east. So they are on the same longitude. So hapa mahali zinakutana ndio tuko na kitu inaitwa Q. This is our Q. So now once tumechora hivyo, we have now known how to put a point on the globe. Sawa? Now I want to use the same points to identify which one is a great circle and which one is a small circle. Is AB on a small circle or on a great circle? Kitu ya kwanza unaenda unaangalia iko wapi. Small circle na great circle tunaangalia the latitude. So angalia latitude yake. Latitude iko kwa 50 north. 50 north hiyo ni small circle. Nilisema anything that is 1 degrees north, 2 degrees north mpaka 90, all of them are small circles. 1 degree south, 2 degrees south, 3 degrees south to 90 degrees south, all of them are small circles. So when you see the latitude is 1, 2, 3 mpaka 89 north, south, that one is a small circle. But now let us see whether Q and P is a small circle or a great circle. Is P and Q a great circle or a small circle? Let us check. P is found where? On P and Q they are on the longitude. You can see the distance here. It is PQ. Mali unaona penye nateremka. Nikitaka kwenda P nitatembea hivi mpaka hivi. Meaning they are on a longitude. If they are on the longitude, that one is a great circle. So this one is a great circle. So PQ is on a great circle. Very important. Having said that, now I think we can go forward and try to now to calculate the distance on a great circle and on a small circle. So before we look at the distance, we need the same thing we need to know. It is the angle difference. Angle difference. The angle difference of 2 points. The angle difference that gives us the angle that we are going to use. So, for example, if I have A 50 degrees south, 140 degrees east, B 50 degrees south, 100 degrees east. Now, how do we get the angle difference in this one so that we can calculate the distance between A and B? You can sketch these ones. If you sketch these ones, these points, you can sketch equator, Greenwich meridian. So 140 east is somewhere there. 100 east is somewhere here. They're on the same side. And then 50 south. 50 south is here. So this is 50 south. So this one is 140 degrees east. And this one is 100 degrees east. So there is here and another one is here. So you can see this is A and this is B. They are on the same latitude but different longitudes. So is this a small circle or a great circle? This one is a small circle. Why? Iko kwa 50 degrees south. Sawa sawa, it's a small circle. Now the angle difference. How do we get the angle difference? So this one, the center yake inakuwa here. The center is coming here, somewhere here at the center. The center, the angle difference here. Now if the two, the latitudes, the longitudes are on the same side, east east. If the longitudes, if the longitudes are on the same side, like now we have east, east, then we subtract to get the angle difference. For example, here the angle difference is going to be 140 degrees minus 100, and the angle difference is 40. We don't bother where they have the same latitude. The same latitude, there's nothing we are going to do. Tunatumia ile ambayo iko different. We use the one that is different, not the one which is in the same. So when the latitudes are the same, we are going to use the longitudes to find the angle different. If the longitudes are going to be the same, 140, 140, we are going to use the latitudes to find the angle difference. Note that. If I have another point here, A, 50 degrees north, 70 degrees west, B, 50 degrees north, 30 degrees west. Angle difference, so angle difference here, because you see they are on the same latitude, therefore we are going to use the longitude to find the difference. Because one is on the east, another one is in the west, so it means itatoka west from 30 ifike kwa Greenwich meridian which is 0, kutoka hapo tena iende mpaka ifike 70. So it is 30 plus 70. So the angle difference is going to be 100. So when we have different longitudes, east and west, we add. When we have difference, we add. I hope you are following. Another thing I want to talk about. Now, let me use the one that is on the same longitude. When we have 50 degrees north, that one is our point S, and 150 degrees west. We have another point K, which is 30 degrees south and 150 degrees west. They are on the same longitude. So the angle difference is obtained. The angle difference, we are going to obtain the angle difference from, angle difference. Because they are on the same longitude, so we are going to get this one of them is south, another one is north. So what that means is this. Let me sketch it so that you can understand. My aim here is you to understand. So 50 north is here, 50 degrees north. And then 30 degrees south is here, 30 degrees south. So, and then 150 west, so that one could be somewhere here. So it means that this point K is here, and this point S is here. So they are on the same longitude, and they are on the longitude. So nikitaka kutoka K niende M, niende S, I will walk this distance. So where does the angle? So this one, because they are on the center is here at the 0. The center is here. So we are finding the angle difference. This is the angle difference theta. We are finding that angle difference. So if they are coming at the center, it means they are on a great circle. They are on a great circle. So the angle difference, we come from 30 to 0, from 0 to 50. So that is when we have south, north, we add. Different hemispheres, you add. It is like for west and east. So south and north, add. South, south, subtract. North, north, subtract. When they are on the same side, you subtract. When they are on different side, you add to get the angle difference. So the angle difference here is 50 plus 30. The angle difference is equal to 80 degrees. Having said that now, allow me to go and calculate, do now a question, and then we will see how to go about it. Now next, we want to look at how to calculate the distance of a place on the globe. The distance depends whether you are on a small circle or a great circle. We will start first by calculating the distance along a great circle. So that's why it is important that you identify whether you are on a great circle or a small circle. Now, let us start with a great circle. Great circle. To get the distance in kilometers on a great circle, in kilometers, you find the formula is theta over 360 2 pi r. Why? What is theta? Theta is the angle difference, because I have told you how to find the angle difference. And then r is the radius, and the radius is always given as 6370 kilometers, the radius of the earth. If you want the distance in nautical miles, then it is simple. The most simplest, it is theta, that is the angle difference, times 60. That one will give you the answer in nautical miles. To calculate the distance of a place on the globe, please first identify whether it is on a great circle or on a small circle, and I have taught that. Distance on a small circle. Let us look at now a small circle. If you have identified that this one is a small circle, so distance in kilometers is given by alpha over 360 to pi r cos theta. Now it changes a little bit. What is alpha? In this case, alpha is the angle difference. Alpha is the angle difference. And the theta is the latitude angle. The latitude, which, because if it is along the smaller circle, the latitude is going to be the same. Inakuwa 50-50 north, 30-30 south. Inakuwa the same. So 30-30 south, alafu the longitude ndio ina change. Therefore, the one that are the same is what we call theta in this case. If you want the distance in nautical miles along a small circle, the formula is simple also. It is 60 times alpha, the angle difference, and then it cos the latitude, which will give you the answer in nautical miles. Nautical miles. So now I will dip into the examples, which will help you to understand even more. Longitudes and latitudes. So kitu ya kwanza tunafaa kujua ni the difference between a small circle and a great circle. Kwa hivyo ukishajua hiyo ndio inakuanga shida kwa watu wengi. So we want to know what is the difference between a great circle and a small circle. Once we identify that, everything is going to be clear. With me here, I have a globe. This globe has this circle, as you can see. There is this circle here. There is this circle at the middle, and there is another circle here at the bottom. I hope you are seeing it. This circle here at the bottom. There is this circle at the middle, and there is another one there. Wewe ukiangalia vizuri, hii circle iko hapa juu. Acha niweke hivi uone. Hii circle iko hapa. Na hii circle iko hapa hivi. Na haka kasako kako hapa. Usiangalie the bottom, hii ni ya kusimamia the base. I'm talking about this circle here and this one. And there is another one here. Zinatoshana? Hazitoshani. Kwa hivyo
This is the equator. This is the latitude where we have the equator. Here, the one that divides the globe into two, the lower hemisphere and the upper hemisphere. This is the equator. So there is something I put here. There is the white lobe you are seeing here. This is the diameter of the earth. So if you look at this diameter and this diameter of the bottom here, as it was shown, this one is small. So the equator forms a great circle. The equator is the only latitude which forms a great circle. The other latitudes to the north and to the south, they are small circles. So the equator is 0 degrees. We have 1 degrees north, 2 degrees up to 90 degrees north. And then we have 1 degree south, 2 degrees south to 90 degrees south. So any latitude below 0 and any latitude above 0 degrees north, 0 above 0 north, that is 1 north, 2 north to 90 north, and any other latitude below the equator, which is 1 south, 1 degree south, 2 degrees south, 3 degrees to 90 degrees south, are all small circles. These lines that go across like this, we call them the latitudes. This line you are saying that, so we are saying that this is the equator, and this line that goes like this, we call them latitudes. So these lines are called latitudes. Any line that goes down like this, another one, this one itself, they are called longitudes. We have said that all longitudes are great circles. All of them are great circles. All longitudes are great circles. It is only the equator that is a great circle. The equator is the only great circle among the latitudes, because the equator is the latitude. So the green meridian, which is at 0 degrees, and the equator is our reference point. When we want to locate a point or a place on the globe, these are the lines we use. So, for example, point A is on 50 north, 50 degrees north, 30 degrees east. P is 50 degrees north, 50 degrees west. The first angle is the latitude. The second one is the longitude. Longitudes are measured from the green meridian. The green meridian is 0 degrees. From here to the west is 180 degrees, and it is west. From here to the east, it is 180 degrees. The equator is 0. We have this down 1, 2 degrees south, all of these are all latitudes. And this one are latitude to the north. The maximum latitude is 90. The maximum another down here, 90 degrees north, 90 degrees south. So let us locate this place on the globe, this point A and B. So to do that, draw a sketch. First, put the equator 0 degrees. Second, put the green meridian, which is 0 degrees. This is the Greenwich. The Greenwich meridian. After that, we have 50 north. 50 north is a latitude, so we start here. This is 9. This is equator, which is 0. So 50, this is 10, 20, 30, 50 will be somewhere here. So this one is 50 degrees north. and then 30 degrees east. This is the green meridian, which is 0, Greenwich meridian, 0. So we have 30 east. East is on the right side, this side. So east, that will be somewhere here, right? So we draw this. This one is 30 degrees east. So it means point A is here. This is point A. Point B. Point B is on the same latitude 50 and 50 west. So west is the longitude. We come back to the latitude, the longitude, and then tunamesha kutoka hapo. Kama hii ni 0, so 50 itakuwa somewhere here. So 50. So hapa ndio 50. 50 west degrees. So we have quoted the 2 points. Kwa sababu hii point A and point B ina lie on the small circle, center yao inakuwa hapa. This is where their center is. That's where their center is. So let me draw a point along the great circle. So point A and B here, they are on a small circle. Small circle kwa nini? They are on latitude 50. All latitudes apart from the equator, they are small circles. Tunataka kuweka point A and B on this group. We want to locate point B and B on this group. The first thing you do, draw the equator. The equator we draw it because it is our reference point. 0 degrees north, 0 degrees south. It is our reference point. Second thing, draw the green meridian because it is our reference point to the west and to the east, 0 degrees. So we have this point A, which is 80 degrees north. So this is, remember, is the latitude. So the latitude we compare with the equator. So north, it is up the equator. So that is will be 40, 50, somewhere here. This one is 80 degrees north. And then 70 degrees east. 70 degrees east, this is the longitude. The longitude, so 70 somewhere here. We put it there. This one is 70 degrees east. Point B, so it means that point A is here. This is point A. Point B is 30 degrees south. So this one tells us it is below the equator. So this is the equator. If this is the equator 0, south begins in here, downwards. So it means 30 degrees will be somewhere here. This is 30 degrees south, right? So, but they are on the same longitude. So they are on the same, this longitude 70. So it means this is point B. Because all longitudes are the great circles, it means that the angles obtained at the center of the earth will be where the equator and the green meridian meet. So their center will be here. Their center will be here. The angle obtained at the center is this angle. Any great circle, the center is at the green, where the Greenwich and the equator meet. For a small circle, it is not the case. The small circle, they meet up there. If there is another small circle here, there is another there. So their center is here and not anywhere else. But for this one, their center is here. That is now important. So distance along a great circle. We can calculate the distance along a great circle in kilometers and in nautical miles. But how do we calculate the distance? I want to use this. For example, the distance from A to B is the arc length of this point A and this one. How do we calculate the arc length? We learned that in Form 1, even Form 2. So arc length is given by theta over 360 to pi r, where r is the radius, pi we know the angle. Theta is the angle. Theta is the angle subtended at the center of the Earth. So I'm going to show you how to get the difference, the angle difference. So this is how you calculate the distance along the great circle in kilometers. In nautical miles, you just get the theta times 60, and that is you are done. So this one will give us in nautical miles. Let us look at this example. The position of 2 points on the Earth's surface are A, 40 degrees south, 40 degrees west, and B is 60 degrees south, 45 degrees west. Calculate the distance between towns A and B along the great circle in kilometers and in nautical miles. Radius of the Earth is 6370. So we go and do it. So let us now locate our point A and B on the globe. It is important that you sketch. So point A is 40 south, 40 degrees south. This is the equator. So 40 south will be somewhere here, right? Will be somewhere here. This is 40 degrees south, and then 45 degrees west. So this is the green meridian. So 45 west will be somewhere there. 45 west. So this one is 45 degrees west. So it means this point here is our point A. And then point B is 60 degrees south. 60. So this is 40. 60 will be somewhere there. This is 60 degrees south. But they are on the same longitude, 45, 45, this one. So it means the point is here, right? So this is point B. So the center of this is here. So it will form this as the center. So what we want to calculate the distance AB. And because it is on a long great circle, the formula is theta is equal to 360. Theta over 360 2 pi r. R we have been given. So how do we get the theta? Theta is the angle difference. The angle of the latitude, the difference. They are on the same side, the south-south. So the angle difference is 60 degrees minus 40. And the answer is 20 degrees. That is the angle difference. So theta is 20. So you put 20 over 360 times 2 times 22 over 7 times the radius 6370. And that one gives us the length AB, the arc length, which is 22.4 kilometers. Now, this is in kilometers. We can now calculate in nautical miles. The formula for calculating nautical miles, you can convert this one or just go direct and say distance in nautical miles is given by theta times 60. So theta we have it is 20 times 60, and that one gives us 1200 nautical miles, like that. You can as well convert 1 nautical mile is equal to 1.853 kilometers. You can as well ask what will be these kilometers. 22 to 4.44. How many nautical? So you can as well convert like this. That is 22 to. So the answer is 1.1 nautical miles, which is the same as this. Distance along a small circle. All latitudes except the equator are a small circle. So this one here is a small circle. But the equator is not a small circle, it's a great circle. So I want to we know the diameter of, and we know the diameter of the, and we know the radius of this one. The radius of the great circle is r. That one we know, and we know it is 663.70 kilometers. But now we don't have the radius, and the radius of the small circle cannot be the same, because the radius here cannot be the same as the radius here, right? So we want, how do we get the radius here? So there must be an angle subtended here, because these lines are parallel. This line and this line are their parallel latitudes. If they are parallel and this is a transverse, so then it means this angle here is this angle here, because they are alternate angles. Very important to know. This angle here, the latitude angle, is the angle subtended this one, because they are alternate. If the same way I draw this one here, the angle here is the angle here. You should know that. It's very important. It is going to help us. And then, so the radius of a small circle, radius of a small circle is given by alpha over 360 2 pi r cos theta. Now I want to define what pi is and what this one is. Because this is a small circle, there will be a latitude there. So that latitude angle is the theta. You can see the angle here, theta. So where alpha is the angle difference, and theta is equal to the angle of the latitude angle. Theta is the latitude angle, and the alpha is the angle difference between the 2 points. So our formula is here, and that is what we are going to utilize. If this one, it will give us in kilometers. If I want the distance in nautical miles, distance in a nautical mile along a small circle is given by 60 times alpha times cos theta. Alpha remains the same, the angle difference. Theta remains the latitude angle. So this one will give me distance in nautical miles along where? A small circle. Along a small circle. So let us do an example. So find the distance between A and B, which has been given these coordinates. So let us locate these points on the group. It is important you sketch. Let us sketch. A is 50 south. South, this is the latitude, so it is below the equator. So 50 south could be here. You write 50 degrees south. And then 35 degrees east. This is the longitude. So the longitude we count from the prime meridian. So 35 would be somewhere here. And this one is 35 degrees east. And then point B is on the same latitude, 50 south, the same latitude, but the different longitude, which is 80 west. So this is the 0. To the west is west, so we are going to the west, which is west. And this one is 80 degrees west. Therefore, we have our point B here. So because this one is a small circle, if it is a small circle, we will draw, the circle will be like this. So where is the center? The center is here. This is point A is here, P is here. So this is our center, and we are, the angle difference is this theta here. That one is our. So let us get the angle difference. So from west 80 to 0, that is 80, plus from 0 to 35 east plus 35. So the angle difference theta is going to be 115 degrees. So we have gotten, this is the angle difference. Angle difference. and the angle difference is what we call alpha, right? The angle difference for a small circle is the alpha. Nimejuaje ati hii ni small circle? Kwa sababu inafita kwa 50 south. 50 is a small circle. 50 south, 10 south, 20 south is a small circle. Hivyo ndio unajua kwamba hii ni small circle. Kwa hivyo now we know that the formula is that alpha over 360 2 pi r cos theta. Na theta tumesema ni nini? Ni latitude angle. The latitude angle here is 50. Unaona yenye inafanana. That is the latitude angle. So now we have 115 over 360 times 2 times 22 over 7 times r. R is 360, 370. Always imepeanwa hivyo. Times cos latitude. The latitude here, you can see it is 50. So this one gives us the distance along AB in kilometers, which is 822 kilometers. So next one is to calculate the distance in nautical miles. So this is a distance in and then in nautical miles, we can simply use the formula 60 alpha cos theta. 60 is a constant times alpha. Our alpha is 115 times this one is cos 50, and this one will give us 435 nautical miles. 35 nautical miles. So that's how you calculate the distance along a small circle and a great circle. Longitudes and time. The Earth rotates on its axis at an angle of 360. One revolution ikisunguka mara moja ina cover 360 degrees, and this one takes 24 hours a day. It takes 24 hours. So let us find what will be 1 hour. What will be the angle 1 hour? So that one will be 360 times 1 divided by 24. So inamaanisha in 1 hour the Earth rotates 15 degrees. So we know that 1 hour is equal to 60 minutes. So if 60 minutes is equal to 15 degrees, what will it be 1 degree? What will be the time for 1 degree? So it is 1 times 60 divided by 15, and this one gives us 4 minutes. So for every change of 1 degree along the longitudes, there is a change in time of 4 minutes. Every time 1 degree changes from 1 to 2 degrees, there is a change in time either to the west or to the east. So this is the green meridian, and this is 0. To the east, this one is east and the west. The time to the west is behind the time on the east. The time on the east is always ahead. The time to the east is ahead. The time to the west is behind. So we look at that. So it means that for every 1 degree change in longitude, there is a corresponding change in time of 4 minutes. Very important. So we are going to use this relationship to calculate the time at the given points or at given places. For example, find the local time in Nairobi, 1 degree south, 37 east, when the local time in Mandera is 4 degrees north, 42 east. You see both of them, they are in the east. So that you should make, and remember, for time, we are considering only the longitude. So we don't care about the latitude. We are interested in the longitudes, because we have said the change in the latitude, in the longitude, not latitude. The change is in the longitude and not the latitude. So we don't care about the latitude. We want to change the angle change in the latitude. So the angle change, the angle difference in longitude is, as you can see, they are east, so it is 42 minus 37, and this one gives us 5 degrees. But we know that 1 degree is equal to 4 minutes. So now we want to find out the difference in time. You will ask 5 degrees will be what? This one will give us 20 minutes. But as you can see, Nairobi is 37 east, and then Mandera is 42 east, meaning that Mandera is ahead of Nairobi. So for us to get the time in Nairobi, which is behind Mandera, the time, we are going to subtract the time, because Nairobi is behind 37. As you can see, it is 37. It is on the west of Mandera. That's the most important thing. Although they are in the east, both of them, but Nairobi is on the east of Mandera. So if in Mandera it is 3 p.m., then Nairobi will be 20 minutes behind. So Nairobi will be 2:40 p.m. If we were getting ahead of Mandera, we were to add the time. This 20 minutes, we add that this one will be 3:20 if it is in ahead of Mandera, or to the east of Mandera. If, for example, it was 50 degrees east. If the local time in town P, 60 degrees north, 5 east northeast, 50 east, is 2:30 p.m. Find the local time of town Q, 60 degrees north, 120 west. So the angle difference along the longitudes is 120. Remember, we have 120 west and then 50 east. So it is from 120 east to the green meridian, which is 0, and then from 0 to 50. So that's why we are going to add 120 plus 50. So the angle difference is 170 degrees. That is the angle difference. Then we shall ask, 1 degree is equal to 4 minutes. What about 170 degrees? So it will be 170 times 4 divided by 1, and this one will give us 680 minutes. So we convert this minutes to hours. You will find it is 11 hours 20 minutes. When you convert it, you will have 11 hours 20 minutes. But we are looking for the time to the west. The question asked time, a local time in town Q, which is in the west, 12 west. From east to the west, we subtract the time. So the time there is 2:30 p.m. Now we are supposed to subtract 11:20 minutes. So change this time into 24 hours. So that one will be 14:30 hours, right? And then we will subtract 20. This one will be 10. 4 minus this one will be 3. So remember, this was PM. So this one most probably is AM. So the answer is 9 asubuhi, 3:10 AM, and that is the time in point Q. In place Q, the time is 3:10. You subtract if the time asked is to the west. We know that speed is measured in knots or in kilometers per hour. So speed measured in kilometers, it is given in kilometers per hour. So something new we are going to learn is about the knots. We know that speed is equal to distance divided by time. So this one, if the distance is in kilometers, divided by time, it will give us kilometers per hour. So speed in knots is given the distance in nautical miles divided by time. So to get the distance in knots, you must have distance in nautical miles and then divided by time to get the answer in knots. That is the only thing you need to know. So for us to get the speed, first we must calculate the distance. We have learned how to calculate the distance. So it is your duty to identify whether the distance you are being asked is along the great circle or a small circle. And then once you get the distance, you divide by the time you are given, you get the speed. An object moves from 30 degrees north, 0 degrees to 30 degrees north, 45 degrees east in 3 hours. Calculate the speed of the object in kilometers per hour and B in knots. So like I have said, first we must get the distance and then we have time, we will get the speed as simple as that. So first we want to know, is this a small circle or a great circle? How do you know? This one is a small circle because the latitude is 30. So 30 is a small circle because we said all latitudes are small circles except the equator, which is 0 degrees. So let us get the angle difference. So the angle difference will be 45, 0, that one is 45 degrees. That is the angle difference, and this one is the alpha. How do we get the distance in kilometers along a small circle? We know the formula, it is alpha over 362 pi r cos theta. Our alpha is the angle difference, so we have 45 over 360 times 2 times 22 over 7 times 6370 cos latitude. The latitude is 30, cos 30. This one will give us the distance as 44, 43, 34.46 kilometers. Now we have the speed, the distance, but we know speed is equal to distance over time. Our speed is our distance is 334.46. and our time is 3 hours. So we are going to have now the speed, and our speed is, we divide by time, which will give us 144.82 kilometers per hour, and this one is the speed. So you see, you need to calculate the distance first. Part B, we are supposed to calculate in knots. For you to calculate the speed in knots, we must have distance in nautical miles. We must have distance in nautical miles. But we know distance in nautical miles is given by 60 alpha cos theta. We have 60, which is 60 is a constant, times alpha, which is 45, times cos 30. And this one gives us 2338.27 nautical miles. So speed in knots is equal to distance in nautical miles divided by time, and that one is 2338.27. we divide by 3 hours, and this one will give us 779.42 knots. Now next we will look at the longitudes and latitudes applications now. How do we apply now the knowledge we have gotten to calculate to solve some problems given? Please share this video and the others that you are watching in my channel. Share them to your friends, your WhatsApp group. You just copy the link there, share, you go to share, copy the link, and then share to your friends, share to groups. That is the only way you can assist me, kwa sababu najua uwezi nitupea pesa, si ndio? Sasa unisaidie ku share these links, share the videos to your WhatsApp groups. Hivyo utakuwa umenisaidia. A and B are 2 points on the Earth's surface and on latitude 40 degrees north. The 2 points are on the longitude 50 west and 130 east respectively. Calculate the distance from A to B along a parallel of latitude in kilometers. So first we need to sketch. That's our sketch. And then this is the equator, 0 degrees. And this is the prime meridian, 0 degrees. Right? So we want to locate the latitude where the A and the P lie is 40. So this is 0, 20 somewhere there. So here, somewhere there we have 40 degrees north. So, and then we are told that the 2 points are on the longitude 50 west. So from here, this is the prime meridian, so to the left is west. So 50 could be somewhere here. So here is point A. And then B is 150 on the same latitude. So 100 could be somewhere there on the other side, like this, somewhere here. So this is the point B. So now we have our point A and B. You can clearly see that A is on 40 north, 50 west, that is A, and B is 40 north, 130 east. We have done that. So calculate the distance AB along the parallel. Remember, this is the equator and it is parallel with this. So we are calculating the distance along the small circle. So this is the small circle here. So we are calculating this here, where this is going to be the alpha. So how do we calculate the distance? First we need to get the angle difference. We have said this one is a small, lazima ujue kwamba hii ni small circle. Kwa nini inaitwa small circle? Iko kwa 40 north. 40 north, we have discussed that in the previous video. Kwa hivyo, so let us see angle difference. Angle difference is 50 west and 130. So kutoka hapa mpaka ufike 0 is 50. From 0 to 130, so we add, that is 130 plus 50. So our angle is 180 degrees. That is angle difference. So distance equal to is given by alpha over 360 2 pi r cos theta. Kwa sababu this one is a small circle. If it is a small circle, this is how we get the radius of that small circle. Kama hujajua, kuna videos nimefanya za latitude, tafadhali zipitie. So now let us, the alpha is this one, and this theta is the latitude angle. Latitude angle. So our latitude here is 40, therefore the angle theta is 40. So which is now 180 over 360 times 2 times 22 over 7 times 6, 370 cos 40. Cos 40. This one will give us 15 kilometers, and we have calculated the distance parallel latitude because it's on the latitude from A to B on this latitude. This is how we do it. So kitu ya kwanza ni kutambua whether point A, B lies on the small circle or great circle. So we have seen it's a small circle. Number B, the shortest distance from A to B along a great circle in kilometers. So now we are calculating the distance between A and B, but this time round along a great circle. Tunajua vizuri that a great circle or inapita kwa longitude. So we are going to calculate the distance AB through A going this way. So if we go like that, we will go along the great circle. And if it is along the great circle, then the center of this great circle, the center here is going to be at this point because that's a great circle. So we are going to have this thing here. So our theta is going to be here. So let us now extract this one. So we are going to have this one, this, and then we have the equator, 0, and then we have this. So this time around we are here AB. We are not going to get this distance AB. We are going to get AB through A this way. So the angle is going to be this one, right? But we know that the latitude here, the angle latitude here is 40, right? We know the angle here is 40. So remember, this is parallel and they are parallel lines. If they are parallel, this one is a transversal, right? So it means that the angle here, it will be the angle here. The angle here, 40, will be the angle here, 40, right? So this is a straight line. It forms 180. Therefore, the angle at the metro is 180 minus 80, which is equal to 100. So our theta now is going to be 100 degrees, right? I hope umeelewa kenye nimesema. Now distance is going to be given by theta over 360 to pi r, because it is along the great circle, So this one will be 100 divided by 360 times 2 times 22 over 7 times radius 6370, and that one will give us 11122.2 kilometers. And you are done. Find the distance between 2 points A, 50 north degrees and 20 degrees east, 50 degrees north, 50 degrees east. So first we in kilometers and then in nautical miles. So let us go straight away. Let us first see, is this a great circle or a small circle? So the good thing you must do is that you have to sketch. Let us sketch first. So this is the equator. This is the green meridian 0, Greenwich meridian. So A is on 50 north. So 50 north could be somewhere there, 50 degrees north. And then we have 20 east. This is 0, so 20 east could be somewhere here. So this one is 20 degrees east. And then, so remember this now is going to be our point A. And then we have B, let me call this one B. 50 north, the same latitude, 50 east. So 50 east could be somewhere here. So this is 50 degrees east. So their center is going to be here. So their center is there. So the angle they form at the center, at their center up there, is that one. Right? So first we get the angle difference. Angle difference is 50 minus 20 because they are on the same side, which is going to be 30 degrees. Because we realized it is a small circle because it equals 50 degrees north, that's a small circle. Therefore, we know the formula. So that is our alpha is 30 over 360 times 2 times 22/7 times radius 6370, but we were given radius 64, so we use that 6400 cos latitude, which is 50. So you use the take radius to be the one you have been provided is the one you use. So finally this one is going to give us 2154.87 kilometers. So that is the distance AB. A and B. Then now Roman 2 in nautical miles. How do we get a radius or the distance a small circle using nautical miles? We know the formula is 60 times alpha times cos theta. 60 is a constant, 60 times alpha, our alpha is 30, cos times cos theta, which is the latitude angle, which is 50, cos 50. And this one will give us 157.02 nautical miles. The position of two towns A and B are 50 degrees north, 45 degrees west, and 50 degrees north, k degrees W or west, respectively. It takes a plane 5 hours to travel from A to B at an average speed of 800 knots. The same plane takes 1.5 hours to travel from B to another town C at the same average speed, full stop. Given that C is to the north of B, calculate to the nearest degree the value of K. So now we want to calculate the value of K. Very important. So let us sketch. This is the equator. This is the Greenwich meridian, which is 0. So we want to locate A. A is 50 north. 50 north is there. 50 degrees north. And then 45 west. 45 west could be somewhere there. Somewhere there. So here is our point A. Our point B is the same latitude but to the west again. So it could be somewhere there. We guess it could be somewhere there. We don't know where it is. So let me say this one is part B. It is on the same latitude but we don't know the longitude where it is. So that's what we are looking for. So here is K. The latitude is K. The longitude, sorry, not the longitude. This longitude is K degrees west, this one. So, but we have been given the distance, we have been given the speed and the hour. So how do we get the distance? Distance is equal to speed times time. So distance is equal to, we're going to be 800 times 5. And this one gives us 4,000 nautical miles. So we have been given distance nautical mile. Ask yourself, is this a small circle or a great circle? Is it a small circle or a great circle? It is a small circle. So we know how to get the distance of a small circle in nautical miles. That is 60 times this change cos theta, where theta is the latitude. So what we don't have here is the change. We don't have that change. That's what we are looking for. So this one is giving us the distance. Distance is equal to this, but this is 4,000 is equal to 60 cos theta times alpha. So alpha is going to be 4,000 divided by 60 times cos. The alpha is 50. So alpha is going to be 103.7. So how do we get K? So K minus 45, because they are on the same side, west to west. This is west and this one is west. The angle difference is K minus 45, and this one will give us 103.7 degrees. So we like terms together. This one is going to be this side. So K is going to be 45 plus 103 48.7. K is equal to 148.7 degrees. But of course, west. Degrees west. Part B, the latitude is C. So the same airplane has gone to C from B to another town C on the same average speed. The most important information is that C is on the north of B. So if B is here, then C it could be there, the north. So it is somewhere there. So this one is C. Here we have C on the same. So you can see clearly that B and C, they are on the same longitude, but different latitude. Therefore, it is on the great circle. So their center comes here. Their center comes here, and we are going to look for this theta, that is the angle difference. I hope you have seen that. So let us now see how to, we have now the distance, because they are going on the same speed, therefore we can get the distance. That is Roman 2. Distance is equal to speed times time. Our speed is 800 times time is 1.5, that is 1.5 hours. And this one gives us 1200 nautical miles. But we know this one is on the great circle, right? How do we get the distance in nautical miles? Distance in nautical mile on a great circle is simply 60 times theta. So we don't have theta, it is the one we are looking for. So 60 times theta is equal to 1200 nautical miles. So divided by 60, therefore theta equal to, this is 20, equal to 20 degrees. Theta is equal to 20 degrees. So C is on X degrees north, 148 degrees, 0.7 degrees west. That is where we have C, right? So we want to get this C. What was C? Because the angle difference is this after subtraction. So it means X, this one, minus that of B. So let me write B is, we had B here. B is on 50 north, 148.7. So you see they're on the same longitude, so we don't mind that. So this X minus 50 will give us what? 20, the angle difference. Therefore, X is equal to 20 plus 50. And that X is equal to 70. So C is 17 degrees north, 148.7 degrees west. That is C. So C is 70 degrees north, the latitude is 70. An aircraft took off from a point P, 60 south, 76 west, and flew due north to a point Q. The distance between P and Q is 5,400 nautical miles. Determine the position of Q. Determine the position of Q. So first let us sketch. So this point P is 65 south. So 65 south, remember this is 0 degrees equator. This is another 0 here. So 60 south could be somewhere there. This one is 60 degrees south. And 76 west. 76 west, this is 0. So 76 west could be somewhere there. So this one here is our point P. Right? So it flew north. So it flew north on the same longitude. It flew north of this to a point Q. So it went to a point Q. We don't know where Q is. Let me just guess that it arrived at that point. We don't know, but we just sketch like that. So then determine the point of Q. Let me call this point here Q. So before we finish, let me show you something. This is latitude here, which is on the north, is parallel to this one. And if they are parallel, if we draw a transversal here, like this, it means this angle here will be the same angle at the center of the earth. Very important for you to know. If I draw a transversal, this is a parallel lines and these are parallel. So from this point and this point, I draw a transversal. This angle here will be the same angle here. Or this angle here, this one will be the same angle here. Very important to know. So that is the knowledge we are going to use here. You see, P, it is going to the center. This latitude will subtend this same angle at the center. Right? So the angle here, theta, or 65, the latitude is 65 south, 65 will be the same angle here, 65 at the center. So this point Q, we don't know where it is, will also subtend an angle X. This angle X here will be the same angle, it will be subtend here, X. So meaning that our difference is 65 plus X to give us point PQ. The angle subtended at the center is 65 plus X. Very important. Therefore, we know this one is on a great circle. How do we get that one? It is simply, for a great circle, it is simple. We know it is 60 times alpha. Not alpha, but theta times theta, because it is on a great circle. But we don't, but this is going to give us the distance, which is 5400 nautical miles. So how do we get the theta? We just divide by 60, divided by 60. This and this. So theta is going to be 90, right? So the angle difference theta is 90. The angle here is 90. But from here up to here, we know is 65. What will it be? X. So X plus 65, the answer is 90. Therefore, X is equal to 90 minus 65. And this one will give us 25 degrees north. So Q is 25 degrees north. You can also as well do it this way. We know that X plus 65 times 60, because this is the angle difference, will be 54. This one will give us X directly, 54. So this one we multiply, so we will have 60x plus 39 would be 5400. 60x will be 54,900 minus 3900. So 60x will be 1500 divided by 60 divided by 60. So x is equal to 25 degrees. So because it went to the north, it's going to be 25 north. Therefore, Q is equal to, or Q is 25 degrees north, comma, they are on which latitude, or they are on the same longitude, which is 76 degrees west.
Maisha ni magumu, lakini never give up. Teseka nimeteseka, aso nimeaso, wala leo umenifungulia, wala mimi sitolia. Teseka nimeteseka, aso nimeaso, wala leo umenifungulia, wala mimi sitolia. Teseka nimeteseka, aso nimeaso, wala leo umenifungulia, wala mimi sitolia. Teseka nimeteseka, aso nimeaso, wala leo umenifungulia, wala mimi sitolia.
A ship leaves an island A 5 degrees north, 45 degrees east, and sails due east for 120 hours to another island B. The average speed for the ship is 27 knots. Calculate the distance between the two islands. Calculate the distance between the two islands. But one thing we know is that distance is equal to time times speed. So distance is equal to time times speed. So we have time, which is 120, times speed, which we have been given in knots. If it is in knots, it means the distance was in nautical miles. So times 27. This one gives us 3240 nautical miles. So we have now distance in nautical miles. From 1 and 2 here, we are asked you to calculate the distance in, first it was in nautical miles. We have done in nautical miles. Next is in kilometers per kilometers. But we have been given here that one nautical mile is equal to 1.8. So we just convert this and say Roman 2 1 nautical mile is equal to 1.853 kilometers. What about 3240 nautical miles? So this one is 3240 times 1.853, and this one gives us 6 kilometers. Next question, part B, is calculate the speed of the ship in kilometers per hour. Speed in kilometers per hour. Now we have distance in kilometers. We have the hours that were 120. We were told here the time was 120, as you can see here. So now we can get the distance, the speed in kilometers per hour. Speed is equal distance over time. Our distance is 6003.72. We divide by 120. This one will give us 50.031 kilometers per hour. Number C, find the position of the second island B. So we can sketch these islands and see where they are. That's part now C, part C. So if we have this one as the group, so where is A? A is 5 north. So 5 degrees north is here. 5 degrees north. And the island A is on how many degrees? 45 east. So 45 east could be somewhere here. East. So here, this is island A. So we are going due east. So the island B is on this side. Could be somewhere there. because it is due east. But now the distance from A to B is equal to 3240 nautical miles. And we can see this one is a smaller circle. You can see this one is a smaller circle here. 5 degrees north is a small circle. How do we calculate the distance in nautical miles on a smaller circle? Distance is equal to alpha times 60 cos theta. Alpha here is the angle difference. Theta is the latitude angle. Our latitude here is 5, so that is our theta. Our angle difference, we are going to, that's what we are looking for first. So it means that 320, it means that 3240 is equal to theta times 60 cos 5. So we multiply, this is the same, 3240 is equal to 59.77 alpha. We want alpha, we want to divide by both sides by 59.77. So we obtain that, we find that. Alpha is equal to 54.2 degrees. So since it is going to the east, then it means we have A, which is 5 degrees north, 45 degrees east. Then B is 5 degrees north, x degrees east. But now when the angle difference is 54, it means that x minus 45, the answer is going to be 54.2. So x is equal to this one, you come here and you add, it comes to the other side, we add, is equal to 9.2 degrees east. Therefore the position now, the position of island B will be 5 degrees north, 9.2 degrees east. And that is it. The position of 3 ports A, B, and C are as shown below. Find the distance in nautical miles between port A and B. A and B. So when you take A and B, they are on latitude 34. That is A and B, meaning they are on a small circle. A and B is on a smaller circle. That is the first thing you need to identify. They are on a smaller circle. Once you have identified that, then you know how do we calculate the distance on a smaller circle. This distance on a smaller circle is equal to alpha times 60 times cos theta. Theta is the latitude, alpha is the angle difference of A and B. So A that is 34 north, then 16 west, and 24 east. So we are going to add to, so theta, alpha is equal to 24 plus 16, which is equal to 40 degrees. So now it is 40 times 60 times 34, which is the alpha, the angle, the theta, the latitude angle. This one will give us an approximate of 90 nautical miles. We have done A, distance in nautical miles, Roman 1, that is. For part B, Roman 2, distance of AB. AB, they are on the same longitude. Or I must have sketched that. If I sketch that, those diagrams here, so that you can be able to see what we are doing. So we have one which is on the west, we have another one on the east, and they are on 34 north. This is 34 degrees north. One is on 16 west and 24. So this one is 24 degrees east, and this one is 16 west. So meaning that this is port A ni 16 west. So this one is A here, and this one is part B, port B. And then we are told that C is on the same latitude 2016, but down is C equal kwa 26 south. So 26 south, this is 0, then equal somewhere hapa. This is 26 degrees south, so equal hapa. Hii ni C. So ukiangalia A na C, they are on the great circle. A and C, they are on the great circle. So the center for this one is here. So the angle difference is here. A and B, they're on the small circle, their center is here. Here. Like that. Now, A and C, they're on a great circle. And how do you calculate the area on a great, the distance on a great circle? A distance on a great circle in nautical miles. It is simply theta times 60. Our theta here is the angle difference. So the angle difference is from here up to here, which is 26, and 16. That is 26 and 34. This is 34 and this is 26. The angle difference, C and they are on the same longitude, so the angle difference is 26 plus 34. 26 plus 34 is 0, that is 60. The angle difference is 60. That is now 60 times 60. The angle difference tumepata hiyo ni 34 plus 26. This is 0, that is 60. So inatupea 36.